Okay, yesterday's class we did graphing exponential equations. So today we are going to graph logarithmic equations. Okay, so let's just recap an exponential. So this is exponential. So what do we remember about it? If the exponent is if the exponent is 0, 3 to the 0 equals 1, right? So that was an idea. We also knew the asymptote was y equals 0, right? We knew that. And we knew another point was always 1 comma base, because 3 to the 1 equals 3. So whatever that base number is. So we're going to quickly graph that. What did that look like? So 0, 1, 1, 3. Does anybody know what kind of coordinate I could put on the other side at -1? What's the height? 1/3. We remembered it. What's the next height? 1/9. What's the next height? 1/27. How far can we go? What's the next height? 1/81. Okay. Too much? Too far? All you need to know then is it's just going closer, closer, closer to 0 and asymptote. Okay, let's add this in today. What is the domain and what is the range? So what's the left to right on this? -infinity to infinity. Agreed? And what's the lowest? 0. What kind of bracket? Soft and then up. Okay. So what do we know about the difference between exponents and logs? Okay, so this is an exponential where the x is the exponent and the y is the result. Okay, so that's an input. We input the exponent, we get out the result. Okay, so what do logs do? So there's your base. This is the result. And logs, the answer to logs is the exponent. So what's happening? From exponent to log, what's happening? What can we actually classify it as? Something we've learned before. It starts with an I. I-N. In what?
Invariant?
No. Inverse. Yeah. Because what happened? The input was x, exponent x, result y, and this time it's exponent y, result x. So what happened? X and y are just switching. It's an inverse. Okay. So what kind of coordinate can we always say should be on a basic log without transformations? 1, 0. What kind of asymptote should always be on a log without it transforming? This was y equals 0, x equals 0. Just switch an x, y. And the other coordinate that we can always say is base, comma 1. So this one had the coordinate -1, 1/3, 0, 1, and 1, 3. So we had -1, 1/3, 0, 1, and 1, 3. So this one has those 3 coordinates where I'm just switching the points. And I'm switching the asymptote to be a vertical. Okay, do you remember what an inverse does physically? It reflects it diagonally. So if I put a diagonal line right in the middle, like that, diagonal, does that look like a diagonal reflection? You see it? That's what inverses do. Okay, what's the domain and range of this log graph? The domain is 0 to the right. And the range, well, it's going to go down forever and up forever. So what do you notice about the domains and ranges of these 2 graphs? They switch because x and y switch, so domain and range switch. So we knew all these things about inverses. Okay, so here's a log graph. What is the base that we're using when we just start? 5. Okay, so here we go. 5 to the -1, 5 to the 0, 5 to the 1. That's how I always start. Obviously with a different base sometimes, but that's how I always start. 1/5, 1, 5. Okay, because I'm going to be doing a log graph, I'm going to write the coordinate output, comma, input, like that. I'm going to write it results, comma, exponent. So I'm just writing it the flipped around way that we did yesterday. 1, 0, and 5, 1. Okay, and the reason is when we do logs, the answer, the output, is always the exponent. Okay, so that's what that would look like.
So when it says out the parent functions, does that just mean before you do the transformation?
Yep, and now we'll do the transformations. You normally can just go to the end. I'm just going to do it step by step, but so yeah, so Callie's question was, what is this? This is just this, log 5x. That's the graph of that. Okay, so let's talk about transformations now. A, B, C, or D, what do you think? A, do we agree A in front? And C. Okay, so now I'm going to go x plus 2, right? Add 2. And negative y, right? That's how we do a C, and that's how we do an A. Okay, so I'm going to change all my points. So this is going to be 2 and 1/5, 3 and 7. So I run all my x's through to go a little faster, run them all through. And now change all your y's. Sorry, my grid isn't even big enough, but. So there are 3 coordinates. Okay, asymptote was here. The only way to move an asymptote in this way is if you move it left and right. So it would have moved to the right 2. If you needed the equation on a question, it would be x equals 2 is the asymptote. And there's the shape. Okay? It reflected. Do you see it? Reflected over the x-axis because of that negative a. Okay, the next one. Okay, I have 2 problems before going about this. What is one problem? Can anybody identify a problem with it? What's that? I don't have a base. If there is no number on the bottom of a log, what is the secret number? 10. So there's a base of 10. Okay, and I have another problem. Factored out. This is a b. It's not factored out. Okay, so if my base is 10, I do 10 to the negative 1, 10 to the 0, 10 to the 1. Obviously you can keep going, 10 squared, whatever, but this is just kind of a nice start. 1/10, 1, and 10. So how do you write this as a coordinate? What, comma, what? So remember when it's a log, you do it results, comma, exponent. Okay, so a super quick snapshot of what that graph would look like is that. Okay, so that's a log graph. Log graphs make that shape. Okay, now let's do some transformations. So we agree we have a B and a C. So how do we work B and C into points? How do you work a B and a C in? Okay, I'll do all the math on the Y's and you guys can do all the X math. How about, it's fair deal? Okay, ready? Negative 1/10 plus 4 gives you, what do you think? 3.9. Right? 4 minus 1/10. How does that sound? Negative 1 plus 4. 3. Negative 10 plus 4. Okay, so 3.9 comma -1, 3, 0, -6, 1. Can you see a shape? Where would you put an asymptote? It originally is here, so what happens to it? Should move to the 4 to the right because of the shift. Do you see a reflection? Do you see that flip? Right? Okay, I think this is the last one. Yep. So ln is the natural log. So when we do a natural log, what can I replace ln with? Natural log is the same of us just doing a log of e. Okay, this e number is the natural log. Okay, does anybody remember the number-ish value? 2.7. Yeah. Okay. So we're going to use a base of e. All right, so I'm going to go e to the -1, e to the 0, e to the 1. E to the -1, that's okay. Go to your calculator. I'm not expecting you to know that one. Does everybody know where their E button is? Obviously flag me down, wave me over if you can't find that E button. It's at the very bottom. You have to push second that. What? E to the X. Yeah. As soon as you push it, it activates an exponent, and you have to push exponent something. Like that? It works? Good? Everyone's good? It's going to be 0.37. Anything to the 0 is 1. And e to the 1 is 2.72. You know what? You're doing a graph, so I'm not going to notice a difference in what you're doing. So if you're just say 0.4, that's good, right? Because I'm not going to look at your number values, I'm looking at your graph, and I can't see a difference on your graph. Okay, so that's my original coordinates. Are you okay to not graph? We're just going to go right to the end. What's the final graph? Okay, so let's put an A on that and a C on that. Okay, make sure your asymptote gets that shift as well because it went right to. You can ask yourself about the basic log shape. Okay, can you tell me what the back of this whole notes book looks like? Is it blank or something? Something? Is there something blank on your workbook? What's the last page of that? Or a recap? Or
On the key then.
on the answer key. Grab your answer key. You have a blank page. Okay, on the back of your answer key, let's make a recap for ourselves. Okay, so exponent, your exponent points should go exponent, comma, result. And using a log graph, your points should always say result, comma, exponent. So this is an exponential graph. Why do those look different? What's different about them? What has to happen in the equations that make these different? If the base is more than 1, it grows. And here, if the base is less than 1, you're going decreasing. What is the most basic log shape? That's a log shape. Y equals log x. Okay, you can reflect that. Okay, I'm going to let you think about that on your own. Those shapes could reflect as well. Okay, what else do we know? We know that it has a y-intercept 0, 1. And then it has no x-intercept, right? Should we write that? X-intercept, it would have none. It would never hit. Okay, unless there was a transformation, right? Because if I shift this down, then it's a good. It could do that. Do I need to write that, or you're good to understand? Unless shifted. Okay, unless there's a shift, and then it could do that. So what would you change about a log graph? Bless you, bless you. It would have an x-intercept. And a y-intercept doesn't exist on it. Again, unless there is some kind of shift, right? Okay, what else do we know? Asymptote. Asymptote. Okay, see all the comparisons? And then we also talked about domain and range. So this domain was infinite, and this was 0 to infinity. Okay, so this is the basic foundation of exponents and log graphs, okay? Obviously, all these details here are the basic, and then transformations can change, all that kind of stuff too.